In this episode, Expanding Logarithmic Expressions, episode 2, coming up, back into action. Hey guys, today I will show you how to expand logarithmic or log expressions. That simply means to break up, to split up your log expression into multiple logs, added or subtracted, by using log rules or properties, if you will. And by the way, this is the second episode, and for the first one you could jump into that, where I give the gist, the idea of how to apply, how to use these properties, and I did a couple of examples. As a quick recap, what is a logarithm, or log for short? It's just a fancy word for a power or index with little bit different emphasis. And if you are down to evaluating and definition of log, you could jump into my another video, which is called What is a Logarithm, where I came up with a ninja trick to help you how to evaluate logarithms with kind of scorpion's tail and stuff like this. Now, say you've been given something like this. So log to the base m of one expression, which is basically located on the top of your fraction, and you are given fraction, you might see, and also you are given the bottom. So since you have a quotient that kind of pop out at you, so your first thing, you start off by using the quotient rule, and all it says that if you are given the fraction inside your log, so the fraction appears as the argument of your log, if you will, it can be broken down, it can be split up into two logs, subtracted, and the first log, the argument, is just the top, the numerator of that fraction, and the argument of the second log is just the bottom or denominator of that fraction, whatever you have inside. Alright, let's apply this rule over here. It becomes, you keep log, you keep that base m, you don't want to change at this point. So log of your top, so whatever you have on top goes over here. It's cube root of x being multiplied by y to the fourth power, minus, we want to subtract off the second log to the base m, and the argument is whatever you have on top, namely a cubed b. So this is your argument for the second log. Now look at the first log. So inside you have the product, so this cube root of x being multiplied by the second factor, the second term, which is basically y fourth. So you want to split it up, you want to break it up into two logs added together by using this product rule or product property. So split it up, so it becomes log base m of cubed root of x plus log same base m of y to the fourth power. Alright, look at the second log from that expression. So again, you have a product inside. A product appears as the argument of your log. Split it up. Split it up into two logs being added together. And look, since I have negative in front, so basically these two logs, they will become negative. But let's just do it step by step. So minus, and I will draw the parentheses, so log base m of a cubed plus, so second log for that one, log to the base m of b. And as I said before, so this negative in front of this parenthesis, that's important at this point to draw the parenthesis, because this negative which is in front applies and distributes to both terms inside. And basically what it does, it flips, it switches the sign in front of this term. So basically the second term becomes negative overall. Now, keep simplifying, keep expanding as much as you can. Keep stretching out. So for the first one, since you have cube root of x, that basically can be turned into a power, a third power of x. So it's precisely the same thing as x raised to the a third power. So this one can be rewritten as x to the 1/3 power. And since we are given powers, the first term, the second term, and the third term, we could apply a power rule at this point. So let's just do it simultaneously. And all it says that your power can be pulled down, can be dragged down in front of your log as a coefficient. All right, let's do it. So I'm going to pull down this a third power in front of my log for the first one. For the second one, I'm going to take this power, namely 4, and pull down in front. And also for the third log, so this power, namely 3, has to be taken out and placed out front of your log as a coefficient. Notice for the last term, it remains the same, so it remains unchanged. And you end up getting, so a third in front, log base m of x, what's left over, plus second log base m, so 4 comes out front of y, minus, we keep subtraction, so power 3 comes out front, log m of a, and minus, so notice again what I said before, so this term becomes negative. So, and we rewrite it as this, untouched. Alright, check to see if any more simplifying can be done at this point, at this stage. So, and the answer is no. So we're done. So we completely stretched out our log. We did expand it. And that your final log expression for that problem. Alright, I have one more coming up. Here's one more. Say you had something like this. Looks a little bit weird and bizarre, and what is a ln? Well, it's just a special logarithm. It's basically a logarithm with a base e. So it's written this way, and ln stands for natural logarithm. That basically means the log with the base e. Log to the base e. And by the way, what is e? E is just a constant in math. It's like pi. And it's roughly equal 2.71 blah blah blah, so it's a decimal, infinite decimal, it goes on forever, non-repeating decimal, and that's another story. Anyway, I'm giving this to you on purpose in case you run into this. But at this point, we don't care about this e. We could just simply ignore it since it will not affect. So let's just carry on with ln, which basically stands for that special natural logarithm, and expand it, stretch it out. Well, since first of all, look at this expression, that argument that is inside of your natural logarithm. First of all, you have outside power, and this is a little bit different from what we did before, from the first and that episode. And since your power appears first, you have to apply a power rule first. So bring this power 2 out front of your logarithm as a coefficient according to this power rule. So power rule has to be applied first. So pull it down in front first of all. So this power comes first. And you end up with 2 being multiplied by ln of whatever you have inside. So namely square root of a b to the power of 4 over root of c cubed. Now, look at these roots inside of your argument. So let's just turn them into powers because we need it later when we're going to apply a power rule again. So just if you come across any roots in your terms, just rewrite them as a powers. So prepare for using a power rule. So keep these 2 in front. And square root of a, square root of anything is just becomes a half power of whatever you have inside. So it's a raised to a half power, in other words. And b to the 4th remains the same. And for the denominator, it becomes just c to the power of 3 over 2. Since the square root means, so it's implied to be 2 over there. Also, for the top of your fraction, since you had these 2 terms being multiplied, we could apply a product rule that basically says that log of 2 factors being multiplied, it's the same thing as 2 logs being added. So we could apply these 2 rules simultaneously at one go. So we could do things at one fell swoop. So it basically becomes, so you keep these 2, and I'm going to draw the parentheses because eventually this 2 applies and distributes to all terms it's inside. So keep it outside for now. So it becomes ln of a half power plus ln of b to the 4th power minus subtract of. So subtract of everything what is on your bottom of your fraction. So it becomes ln of c 3 over 2. The good rule of thumb, whatever you have on top, take it as a positive ln or any log. Whatever you have on bottom, it comes with negative. If I have one more term, let's say d whatever, on bottom. It comes also with negative, so I would subtract it off. Alright, so keep simplifying, keep expanding, keep stretching it out. So since you have powers 1, 2, 3, so drag them down as a coefficient in front. So it needs come down in front as a coefficient. So keep these two out front. So it simply becomes a half being multiplied ln of A plus 4 ln of B minus 3 over 2 ln of C. And finally, the last step, I hope. So, as I mentioned before, these two needs to be in distribute. So, you simply take these two and multiply to both terms inside of your parentheses. And it becomes 2 times 1 over 2. It simply becomes 1. So, I'm going to ignore this one and write just ln of A. Plus, so 2 times, let's put it like this, 2 times a half, 2 times 4, and finally 2 times the last term. So 2 times 4 gives you 8 times ln of B, and finally minus 2 times 3 over 2. So since 2 goes on top, 2 and 2 will cancel each other out, disappear, drop off, so you would be left with just 3 being multiplied by ln of C. And that's your final answer. That's your final result for that log problem. Alright, I hope it helps you. And if you need, by the way, the help with condensing, which is basically the opposite of expanding, so you could check out my condensing logarithmic expressions video. Thanks for watching and train your brain. So I hope it did help you. I know everyone hates math, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new videos. So I know everyone like maths. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below.